Alright, what's wave-particle duality? What in the world is this concept of wave-particle duality? Well, if you just hear the name, you'd think, well, it's obviously duality of wave and particle, right? I mean, that's pretty much just what Wikipedia put. Wikipedia is really helpful in this research. It says, wave-particle duality is the concept in quantum mechanics that every particle may be described as either a particle or a wave. You know, that's a really helpful description, Wikipedia. I definitely could not have guessed that from just the name of wave-particle duality. So I had to continue my search of finding out what wave-particle duality is. And what did I find? Well, I found the history of it, starting with the photoelectric effect with Einstein in 1905. And he suggested that the photoelectric effect hinted at wave-particle duality. And of course, I had to find out how in the world did it actually hint at wave-particle duality. And pretty much the wave-particle, the photoelectric effect, is that you shine a light on metals, right? And this led to an electric current within the metals. And this came from emitted electrons. And the higher that the light's intensity was, the larger number of emitted electrons. But the paradox with photoelectric current was that the electron's energy increased with the frequency of the light rather than the intensity. And this kind of just didn't fit with the entire thing of the electrons being a wave, or the photons being a wave. And this caused a lot of problems, especially within the world of physics at the time. Where should I move this bishop? This seems like a good square. Now where was I? Oh yeah, so this led Einstein to pretty much hypothesize that energy really came in quanta. And this led later on the years with Planck coming up with E equals hv, where E is the photon's energy, h is Planck's constant, and v is frequency. And this caused a relationship to form between the energy of the photon and the frequency of the light rather than the intensity of the light, meaning that the energy of the photon now was independent of the intensity, which now introduced pretty much these particle aspects to waves of what was previously thought as a wave. And now later there's another guy, his name was Louis de Broglie. I have no idea how to say his name. Louis, I have no idea. Pronunciating names gets difficult. But he made a really clear equation that makes wave-particle duality more understandable, I guess. He said lambda equals Planck's constant divided by momentum p. And of course lambda is wavelength, which is a wave property. H is Planck's constant, and p is momentum. And momentum is actually it's pretty much this, it's pretty much a part of a particle. A wave doesn't really have momentum. Momentum is m times velocity, so there's mass. And energy generally doesn't have mass. A photon is thought to not have mass, but if it has momentum, it must have mass. So this introduced wave-particle duality through de Broglie's equation. And that's all nice and all, it's mathematical, but what conceptually really is wave-particle duality? You just have to kind of think about it. We always get caught up in these math, and it's kind of hard to visualize sometimes, especially for, regular people. I can't really think of it mathematically. Like, if you suddenly threw in quantum gravity equations or Einstein's field theory, I wouldn't be able to understand it, right? So conceptually, what really is wave-particle duality? And in order to answer that, we have to kind of break down what really wave-particle duality is. What's a wave? What's a particle? Those are two main questions that you really have to ask from here. And now I will answer that as soon as I find out the move I want to make here. This queen is kind of just here. He just pushed back. It's playing like alpha 0. It's very scary. I kind of want to break open the center. Yeah, actually I'm pinned. Maybe the king back. Maybe activate my rooks. Might be a good idea. This is a weakness. I'm thinking just move here. Activate. Okay, where was I? Yes. So I'm going to ask, what's a wave? And so what I did was I typed wave into Google, and what Google gave me is that Wave is a company that provides financial services and software for small businesses, and is headquartered in Toronto, Canada. And I realized that's not the wave I was thinking of, so then I typed in wave in physics, and what it gave me was this. You get that it's things that change in a medium. And that's my simplified version. If you quote it, what it tells you is that a wave really can be thought of as a disturbance or oscillation that travels through space-time accompanied by a transfer of energy. And I didn't understand that. I don't understand what that means. That's a really complicated word. Oscillations that travel through space-time. What's space-time? Are you trying to make this super paradoxical? I think I now have to make a video on what the heck space-time is. Is space and time really the same thing? Is time really the fourth dimension? Is there really only 3 dimensions of space, or are we talking about string theory where there's going to be like 10 space dimensions, 26 dimensions? If you use M theory, it's like 11 dimensions. What the heck is a dimension anyway? I don't know. Where was I? I was talking about something like, oh yeah, space-time dimensions, yes. Yes, a wave is a disturbance or oscillation that travels through space-time, and is accompanied by a transfer of energy. And if you think about it, really, energy, you really can't like make a physical image of what energy is at the end of the day. You might think of an orb, but energy really isn't an orb, it's a wave if you really think about it. It's oscillating through space-time. He just made a move. He played c5. I might play b4. He might bring this over. I might just trade. I don't know. This is interesting. I'm still thinking this. I could play this now actually. Just kind of break it down. I don't know. This might be my entire plan and might crumble. If he plays here. Should be fine. Yeah. So that's kind of what a wave is. I just think of it as something that changes through a medium like air or water and transfers energy. I don't really know how to say it in simpler words than just transferring energy. There might be a better way. It shares energy, like a communist, because sharing is caring. Anyway, so now I ask my second part of the question. What's a particle? And it gave me that particles are just things that float in the atmosphere. I realize that's not really the particle I was talking about. So you type in particles in physics, because you always have to add the physics part, because it's just gets more complicated. And what they give you, of course, is that a particle, and they just start talking about elementary particles. They talk about quarks and leptons. They talk about all these different bosons. And I'm like, okay, that's for something else. I'll do something on that later. I kind of want to talk about that right now at this moment. This opens up the queen. That's okay. We have to make this exchange. Come back here, protect this. You might try to push in again. I'll just come back. Okay. Yeah, it's fine. This is fine. I can even come up here. I don't know. Nah, I'll keep my knight here. Yeah, so I was answering what in the world's a particle. Turns out there isn't a lot of good answers on the internet. Yeah, I clicked on this link from quantamagazine.org. You know, that's a reliable source because of the name Quanta. Sounds like they're pretty experty at quantum mechanics. And it has the .org. Yeah, I don't know if you guys ever went to school, but .org is supposed to be a mostly reliable resource because it's an organization. Hopefully it's verified. And what it told me, of course, is that it might be a collapsed wave function, or that it might be a quantum excitation at a field. It also tried to use string theory to prove that it was vibrating strings. And you know, just as a little kid, as a high schooler trying to find out what a particle is, I didn't need to have some sort of mental breakdown at 8 p.m. trying to find out what a particle is. And I read this entire article that was very well crafted but very confusing, and I didn't understand like half of it. And you know what it told us at the end? It told us the short answer. Of course, they couldn't just put the short answer at the beginning of the article because then people would just click off the article. But the short answer is that we don't know. And that's the short answer. They don't know what a particle is. So I'm just a little high schooler trying to find out what a particle is. And they're telling me that a bunch of dudes with PhDs in physics and quantum stuff tell me they don't know what a particle is. And there's other people who say it's like a singularity. I'm like, a singularity? They're telling me particle is singularity, but a particle also has to have mass. If a particle is infinitely small and is a singularity, does it really have mass? It can't just be a singular point. And you had to ask, what in the world is a singularity then? It just gets super confusing after a while. And this guy just made a pretty good move. Knight b6, attacks knight. He has 3 attackers on my poor knight here. He's gonna die. If I release the pressure, he's gonna come back and haunt me in my dreams. I could just trade. He has to take back. No, yeah, he kind of has to take back. I can't do that because the en passant. I can just transfer back. Takes. I come out with an extra knight. This is hanging. Of course, I can just shift over. If he takes, I shift here. It's all well protected. So I'll just take the knight. Okay. Now where was I? Oh yes, I was complaining about how in the world I can't find out what a particle is. And so, I don't know either. I have no idea what a particle is. I'm still trying to find out what a particle is. Of course, they don't tell me what a particle is. They're keeping secrets from us. It's very sad. I could just tear open. Okay, I misclicked that. I mouse slipped, but luckily it's an okay move, I think. Yes, that should be an okay. Okay. So yeah, basically what they come up with is that a particle is infinitely small and it somehow has a mass and a volume. And that sounds kind of contradictory. I guess people can't come up with a simple system of what a particle is. But think about it, if you really think about it, aren't waves just made of particles technically? I mean, if you think about it, like a water wave, you go to the ocean, you go to the Pacific, I guess the Pacific doesn't have waves, you go to the Atlantic has scary waves, giant waves that just engulf you. And these waves are huge, they're humongous. But it's made of H2O, isn't it? Isn't the medium just made of particles? So maybe it's just that the waves are just, I don't know. Maybe the medium themselves are made of particles. And it's just not what I'm thinking of. I don't know. This guy's doing something. I don't know. It's a one-time attack. It's not a bad idea. Go back here. Go here. Go here. I think just go here. Yeah, if he takes, I'll just take back. I mean, there's no harm in it. No, there is harm to it though, because he takes my pawn. Oh no, he can come down here now. That's a horrible arrow. Brooks does not move like that. Who's here? Yeah, so maybe the medium's made of particles. Maybe the medium itself is a wave. Well, if the medium itself is a wave, does that mean that waves are just particles and they're the same thing? What do you think about what if a wave and a particle at the fundamental level is just a third different thing? It's not a wave or a particle, it's just a third thing. And we can call it something like, I don't know. What could we call it? We could call it something like, I'm trying to think of a name. We could combine particle and wave, and we can call it pave. But that's already a word, so we can call it a warticle. Warticle, because water, it sounds like water, I don't know. I've given up. It's okay. I kind of just want to tear this open. I don't know. Now they have infiltrated, which is a little concerning. It's only just slightly concerning. If I move here, it blocks this in, but really doesn't accomplish anything. Kinda just want to make an open file for my rook. Checks here, here, and this is very good because I have this. Better move, just take here. Come in here like this. I don't know. That looks scary, but it really doesn't do anything, honestly. Does not accomplish anything. But I'll just take here for now. Anyway, I was talking about this third new thing, and I'm just going to invent it. It's called a watercolor now. Wave-particle duality is just explaining the incredible concept of particles. It's wave and particle combined. And it has both properties of wave and particles. It has momentum. It's just, it may look like it doesn't have any mass, but really maybe energy does have mass. Who knows? I mean, if you think about it, if there's enough energy, it can become matter, right? Or matter can become energy, so why not vice versa? I mean, E equals mc squared, right? Energy can equal mass if there's enough speed of light. If you travel fast enough, would you technically become energy? Just pure energy. So does that make energy matter too? I mean, I feel like that should be a thing. I feel like it is a thing, actually. Who knows? I feel like someone should know. Maybe God knows. Who knows? Maybe particles is just an energy's way of expressing themselves. Who knows? Who knows? I'm just gonna fall back here. I'm just gonna kind of transfer, maybe, like this. I do not know where to go from here. I have no idea. I will move here and threaten this thing. I don't know if that's really effective, but it might do so. Okay, he has moved here. I could sacrifice. Sacrifice might be an option. I don't know. Yeah, so wave particle duality. I mean, it's super confusing. Although people keep telling me it's just simple quantum mechanics. There is no simple quantum mechanics, guys. Quantum mechanics is just confusing overall. You know what I mean? I might just sacrifice. I will sacrifice. You should not accept that sacrifice. I will sacrifice. I'm already down material. I can sacrifice. Wave particle duality. Yeah, I still think watercolor is a better name. Well, I mean, scientists really have a problem with naming stuff. Wave particle duality. Who would think of that name? I mean, it's a very simple name. Wave particle duality. I feel there should be a better way to name it. That's why I made pay for watercolor. I don't know. I do not know. Yeah, but if you think about it, maybe they are just the same thing. I don't know. They very might well just be the very exact same thing. It's like a solid and a liquid. They could become each other. If you melt a liquid, okay, that's not right. If you melt a solid, if you melt a liquid, that's concerning because that just becomes a gas. But if you melt a solid, it becomes liquid. But if you freeze a liquid, it becomes a solid. Same thing. I mean, what if you melted matter? Okay, if you just melt matter, can you melt matter? Is that even possible? Can you melt a particle? Can you melt a singularity? I'd be concerned if you could. What would happen if you melted a singularity? That'd be kind of scary, not gonna lie. I don't know. If you melted a singularity, it really wouldn't be a singularity. So what kind of properties does a singularity have? Is it just massless? It's just kind of a point in space? Singularities even exist? I mean, there's like Planck's length. Is like Planck's length just the singularity? Is it even possible to have singularity in the world for real? I don't know. It's all very confusing. But if you melted a singularity, what would it look like? I mean, you probably can't even see a singularity. We can't see singularities, but if you melted a singularity, would it just become like a liquid singularity? I don't know. I don't know. Or for that matter, what if you freeze energy? Well, if you freeze energy, doesn't it just become... Can you freeze energy? How do you freeze energy? Technically, if you're just freezing a cooler, you're freezing energy. I mean, energy, really... Can energy become solid? I don't know. You think about it, if you freeze energy, you have to use energy to freeze the energy. So does that just kind of defeat the purpose of freezing energy if we can even freeze energy? I don't know. I kind of don't want to answer those kind of questions. Ay. You know, I realize you can just go here. I realize that now. That's kind of concerning. That is a little concerning. I don't know. Yeah, I'd probably just take here. That's the best move. Yeah, just take it. I mean, just try to get a material advantage, really. Move here. Well, is that a good move? I don't know. Actually, that might not. Well, I don't know. Anyway, I was talking about freezing energy. Freeze energy. What if you just heat it? Okay, if you just heat up energy, that just makes more energy, right? The parts just get more excited. I mean, or if you think about it, can you really heat energy, or are we just talking about heating things with energy, or just freezing it? Makes it less energetic. That doesn't mean you're freezing energy. You're just reducing energy. It's not freezing energy. So have people really tried heating energy? Well, I mean, of course, there's a conservation law of energy, law of conservation. Energy can't be created or destroyed. So, But is there a way to make energy more sluggish? What if you just made energy less efficient? Would that just be reducing energy, or is it just the same amount of energy? I mean, think about it very hard. Just like how my opponent is thinking very hard about this bishop move, this very questionable move that I've just made. Honestly, it's not really a sacrifice. I mean, if he takes here, I take here, he's king. That's checkmate, actually. That's checkmate. Yeah, he cannot take, because this is a checkmate right here. I didn't even realize checkmate. I just saw I was pinning this. Oh no. No, he moves here, I move here, and then just colors. This is just, he's just dead. He's just dead. He can't take. He cannot take that. Wow. Will chess.com say it's a brilliant move? I don't know. I come up with a lot of weird stuff. I come up with excessively weird things. Yeah, he's thinking for a while, Mr. MV Siri from Brazil. Brazil seems like a nice place. Oh wow. Oh wow. Oh wow. That is an interesting move. Okay. Okay. Okay, that is an interesting move. Just move here. Yeah. Yeah, I'll trade. Interesting moves. Anyway, my opponent's down to 4 minutes. I'm still really thinking about it. It's disturbing me. No one really has seen energy if you think about it. The only time we can really think about energy really highly is like the atomic explosion. You know, like if you drop an atomic bomb, technically you're just converting a bunch of energy, aren't you? And that's kind of disturbing to think about. It's just a little disturbing. Yeah, I mean, okay, that's a move actually. Yes, this knight is no longer moving. I do not believe he can move anymore. I don't know. I'll just come back around. Yeah. a very slow process, so you still have a lot of threats though. I don't like this. This is scary. I don't like this. This is also kind of scary, I mean. Oh snap, actually. I need to move my king. That's the first point of order. My king needs to get a safety. My king is very insecure right now. I didn't even see c4. c4 is actually a strong move. What was blocking this anyway in the first place? Hold on. Nothing. Okay, my queen used to be here. That's why I could play that. Okay, well, we're just gonna hope. Okay, what do you play? Okay, he played his rook out. Hold on. Isn't that like a huge mistake though? I can infiltrate. I can infiltrate very, very quickly. I can oh my gosh, my words, infiltrate. Infiltration is possible, very possible. He has to move here or here, I mean, probably won't move here. Yeah, he has to move here to protect this. So he's gonna move here. And then what? I mean, I'm just on the other side of the board. Alright, I'll move here for now. Hopefully I just did not make a fatal mistake. I just left this hanging, I realized. I just left that hanging. That might be a mistake. Yeah, it probably is a mistake. I can just go here though. Problem with this is that I'm just thinking about melting like energy, and then I'm just having to like try to play this position. And it's like, okay, what's actually happening? Like, what am I actually doing? It's all just confusing, very confusing. Like, I just come up with these crazy ideas, and then like I try to think about them, but then I'm simultaneously trying to survive. It's not a good idea. It is a very bad idea. I'm just saying, it's a very bad idea. I was not expecting this game to last so long. I've only used like, well, he's used a lot of time. He's thinking very hard though. It's good to be meticulous, I'd say. Like, it's hard to lose on time with these, especially since there's like a 10 second interval. I don't know the intervals. Hey. I also need to think of what else to talk about. So I just talked about wave particle duality. And you know, I can just talk about nuclear fusion next, because I'm actually kind of curious. What actually happened when they dropped the bomb? Like, people people actually just disintegrated, didn't they? Like, as soon as it exploded, like, they just kind of evaporated into energy, like pure energy. And that also comes into play, like, is it actually possible to go so fast that you just kind of disintegrate? So does that technically mean that physically it's impossible to travel over a certain speed, like over the speed of light? You can't travel over it because then you just become pure energy. You know what I mean? Like, photons go at the speed of light, but aren't they just packets of energy? They don't have mass, they're just point elementary particles. So that'd be interesting to think about. I might do something on that next. Okay, he's down to his 19 seconds, 18, 17, 16, 15, 14. Okay, that's a bad move. But is it really a bad move? I'm trying to think. He still has this, actually. If he just takes here, I can just come back up, just start take him out. I really don't like this move, though. Like, that's super annoying. Hold on. But this isn't going anywhere. That's true, it's not going anywhere. Well, it could go here, but the king is in a tight spot. Kind of. I don't know. Kind of a tight spot. He does have 20 seconds. I'm probably just gonna go up here. Hopefully he doesn't play this. If he plays that, I'm actually kind of screwed. Right now I do have this move. It's kind of a powerful move. Okay, you did not see that move. That is good. I do not like this move. That is a scary move. Okay, gonna check here. I think it's almost over. Kind of hoping it's almost over. Oh. Okay, it's a good move. I'm gonna take here, take this. Yeah, it's almost over. Don't forget, yeah. I don't know if he's gonna recover from that. That's a pretty big blunder. He just lost his rook. 10, 9, oh the pressure, 8, 7, 6, 5, 4, 3, 2, 1. Oh, he moved. 9. Oh, he moved. Okay, he found the move. He did find the move. Which is kind of annoying. I'm just gonna. Okay, don't mess up here. Okay. He actually can't take anything because of this. I realize that now. I can just. Okay, he won. I won by resignation. Alright, that was pretty cool. Don't forget to like, sub, and I guess I'll see you next time.